All right. Well, I hope everybody's having a good day. It is certainly good to see everybody. Just a few housekeeping items before we go ahead and get started. The big item, of course, is tomorrow you have your second exam. It's going to cover normal distribution, linear regression, correlation coefficient's going to be on there. I put a Spearman's rank correlation coefficient. Also, t-test problem is going to be on there. So definitely bring your notes with you tomorrow. You can use them on the exam. Okay, calculators are definitely going to be very useful to you. If you are looking to retake the normal distribution quiz, I believe today is the final day to go ahead and do that, because I want to say we took it last Tuesday. You just have to have the assignment done prior to that. I did introduce you guys yesterday to what's called Rhythm. It's an SEL app that the district, well, no, I shouldn't say district, the campus is adopting. So how do we go ahead and log on to it? I'm glad you asked. If we come over here, now you have to be logged in under your school account, but when you go to Google here, go to the waffle icon or the 9 dots, click on it. You're going to scroll down until you see this C icon for Clever Portal. It's going to bring you to this Clever Portal website right here. You'll scroll down a little further, and here is the R icon for Rhythm. So you'll click on it, and it should take you right there. At the very top of your screen, you'll go ahead and click Get in Rhythm and Get Me in Rhythm, and you can go ahead and start inputting information. How are you feeling today? Is there anything bothering you? Things of that nature. That you'd like to go ahead and communicate with your teacher. I would encourage you to go ahead and take a few minutes, kind of poke around the website. I need to do the same thing because I was just introduced to this on Monday, and I'm not quite sure exactly how everything works this yet. But we are officially starting this on Tuesday, because Monday, of course, we have another day off. Okay. And the plan is to go ahead and do it during the announcements. The announcements are roughly 2 to 3 minutes long. So they're thinking in the 2 to 3 minutes, whatever period announcements happen to be, we should be able to log on, kind of talk about how we're doing, and, move on from there. Badges. Everybody got your badge? Fantastic. You guys always do a great job on that. Phones. Okay, let's go ahead and put those to the side. We are officially beginning, unless there are any questions. No? Okay, then let's go ahead and get started. Let's see here. Okay, so we've been talking about chi-squared test for independence. Now, the observed data that is collected for us, that's contained in what we call a 2x2 contingency table, or when this one's a 2x2, it's called a contingency table, or we refer to it as a two-way table. Now, the idea behind correlation coefficient, chi-squared, is that you're comparing these two quantities, and basically you're wanting to tell, is there any type of association between them? We call it association. So if we say that they are independent, that means there's no association between them, no relationship at all. If we say there is an association, they are not independent of one another or dependent, then we can go ahead and hopefully infer what the relationship is. So the chi-squared test will indicate yes or no if there is a relationship. Again, association, it's just not going to tell us the nature of that relationship. You would then have to go ahead and figure that out. So we talked about expected frequency values, finding the values that we would expect to get if the two quantities were indeed independent of one another. And we did work several examples where we were finding expected values for specific quantities. Then we moved on to finding the critical value. We find the critical value using the significance level. Remember, that's the percentage at which you're testing the chi-square exam. 1%, 5%, 10%. Okay, and you also use the size, what we call the degrees of freedom. Both of those together helping to find your critical value. So the degrees of freedom is found by taking the number of columns minus 1 times the number of rows minus 1. Okay, then we talked about a little more about degrees of freedom. We got a little more into the p-value. We talked about a few shortcomings for the chi-squared test for independence, and there are basically 2 of them that you need to be aware of, really only if you're going to be using the chi-squared for your IA, which some of you very well might. If your degrees of freedom are 1, your results could be called into question. Okay? If you have expected values less than 5, your results could also be called into question. Now, with the expected values being less than 5, if all of your cells combine, if that still represents less than 20% of all of your expected frequency cells, you should still be okay. But if it's definitely more than 20% of your cells that are less than 5 for the expected values, again, your results could be called into question. So what I did, I went ahead and went through my YouTube page. If we go to Google here, let me go ahead and scroll on down. You'll notice I did go ahead and put, went a little too far, on our current week right here, you see where it says Yates continuity? That's the correction test that you're going to need if either of those two instances occur. So if you don't have degrees of freedom, that's 1, or you don't have any expected values that are less than 5, then you don't have to worry about it. Your results should be valid. Okay, but just in case that happens, I went ahead and posted the video, so you can go ahead and take a look at it. But please feel free to come talk to me anytime if there ever is that issue that pops up. Okay, all right. Then we started working some examples here, and really we just looked at how to go ahead and do it formally. Here's the big idea. If the chi-squared value that you calculate is less than the critical value, we say they're independent and we accept the null hypothesis. So that means we fail to reject. That means there's no relationship between the two. One does not rely on the other in any form or fashion. Now, if our calculated chi-squared value is greater than the critical we determined, then they are not independent or dependent. That means there is an association, and we would reject the null hypothesis. Now, there was one other thing that I brought up yesterday. It was the p-value. Think of this as an additional way of confirming whether or not your original conclusion is correct. So based on the p-value, here's what we have right here. If the p-value is less than, now here they're using 0.05, but you're comparing your p-value to your significance level. Remember, this also includes the 1% and the 10%. So if the p-value is less than 0.05, we reject the null hypothesis. That means they're not independent, they are dependent. Okay? If p is greater than your significance level, we do not reject the null hypothesis. In that instance, they are independent, again, hence no relationship. Okay, so let's go ahead. I believe we did finish up this problem, correct? I thought we did, because after this, now we're just on to examples. Okay, so this is the assignment. Okay. What I thought we'd go ahead and do, let's go ahead and work one of these together. We'll go ahead and do it by hand. We'll go ahead and do it using technology. And then I'm just going to go ahead and turn you guys loose. Let you go ahead and practice this. Now, remember, is chi-squared on the exam? Okay, it is not. Chi-squared is not on the test tomorrow, so we don't have to worry about that. Let's go ahead and say the homework will be due on, I believe I said Tuesday. Let's go ahead and say Tuesday. I might need to double check that, but let's go ahead and say Tuesday. That gives you plenty of time to go ahead and finish it up. And I believe I have a quiz scheduled for this next Thursday. Okay, so that'll work out better. We can go ahead and talk about it on Tuesday, answer any questions, and then it's still somewhat fresh in your mind as compared to going a whole week. All right, so let's see what number 1 says. Or excuse me, before I even continue, are there any questions about chi-squared? Anything confusing anybody? Expected frequency values, the p-value, okay, degrees of freedom, critical value. Hey, we're gonna get that. I went ahead and created a quiz yesterday. The question was, are we going to go ahead and get this chart? And I'm assuming you're talking about this chart right here. Now, I did go ahead and incorporate that into the quiz. So based on the degrees of freedom you find and the significance level, you'll have to go ahead and figure out, which one is correct. But usually one of two things is going to happen, either on the test or even on the paper exams that we're going to have in May. I believe it's 6th to the 7th of May we're going to have those. Either the critical value is simply going to be provided to you, or you'll be using the p-value to help figure out if there is or is not an association without the critical. That's why I really want to emphasize the p-value, because a couple years ago, as I said yesterday, I got caught on that and my students kind of paid the price. So I don't want that to happen again. Okay. But on this quiz, I did provide the table. Okay. All right, good, good, good. Any other questions? Everybody at home still hear me okay? We're good to go? All right, well, let's do it. Okay, this contingency table shows the responses of a randomly chosen sample of adults regarding the person's weight and whether they have diabetes. At a 5% significance level, the critical value of chi-squared is 5.99. So see, they've already provided that for me. So I don't need to worry about finding the degrees of freedom. I don't need to worry about using the significance level in the chart to go ahead and find that. Now, just for practice, let's go ahead and find the degrees of freedom. Okay. How many rows do we have? 2. So 2 rows minus 1 times, how many columns do we have? 3. 3 minus 1. So that's going to end up being 1 times 2. So the degrees of freedom here should be 2 for a 2 by 3 matrix. Everybody okay? All right. So test at a 5% level whether there's a link between weight and suffering diabetes. Okay. Well, the first thing I'm going to go ahead and do, remember this F dot right here, F sub 0, or F sub O, depending on how you read it. That's the observed data. So the data that I actually see here, I'm just going to go ahead and put in the first column. So 11, 19, what do we have here? 26, 79, 68, and 69. Okay, so we got that. Now we want to go ahead and find the expected frequency values. So for that, we're going to need the column totals and the row totals, because right now, I don't know how many people are involved in the study. Is everybody okay with that? Okay. So I'm going to go ahead and get a calculator so I can keep up with you folks as well. So for that first column, I got 79 plus 11, which is going to give me 90. Okay, so that's easy enough. What's a 19 plus 68? 87. Now I need 26 plus 69. What's that, 95? Correct? Okay. Now just so I can go a little faster here. People are trying to graph. It's funny, we're talking about graphing sinusoidal functions in pre-cal, and every time I turn on the calculator, I see someone trying to plug it in the calculator. Sad. Anyways, what do we got? 11 plus 19 plus 26, 56. Then 79 plus, what do we got here? 68 plus 69. I'm getting 216. So let's see, 216 plus 56, 272. And let's see, will 90 plus 87 plus 95, it does give me 272. So 272 people belong to this survey. Okay. Everybody okay with the numbers I'm getting so far? Anybody confused? Okay. Now let's go ahead and find the expected frequency values. So let's go ahead and break this up. Let's go ahead and say, Daniela, could you go ahead and find the expected frequency values for these right here? Diabetic and non-diabetic who are light. Dylan, go ahead and help me out with the 2 middle. And then Zuzu, we'll go ahead and have you find the last 2 cells right there. Now, for those at home, and we don't want you to feel left out either, Annika, why don't you go ahead and help Daniela look for the first 2. Light, diabetic, and non-diabetic. Ryan's helping you? Yeah. Okay, so Ryan's helping Dylan. Michelle, why don't you go ahead and help Zuzu with the heavy diabetic and non-diabetic. And then Alwyn, why don't you go ahead and help Daniela and Annika find the first 2. Now, does anybody have any questions about how to find the expected frequency values? Does anybody not remember? Hello. Okay. Thank you. Until it. Okay, so I'm going to go through these one by one. So for diabetic and light, okay, what should we be getting? And let's just go ahead and round it to, let's say, 3 decimal places. Okay. So Daniela, Annika, what am I getting for this first cell right here? Light and diabetic.
I have a question.
Yes, ma'am.
Really, is it you have to multiply like the sum by what is it?
Yeah, so the question is, we have to multiply the sum, so you're on the right track. So if
okay.
I want this cell right here, I'm going to multiply that column total by that row total. So I'm going to take 90 times 56, and then we always divide by the number in the survey or the sample.
Okay.
Okay. So Daniela or Annika, do either of you have that first one? We'll see if it matches up.
So is the first one,
So Annika has given me a value. Daniela, what do you say?
is it, I don't know if I did it correct.
That's okay. Tell me what you got.
1.13.
What is it?
1.13.
We're a little off. We should be getting 18.529. Now, because we're doing that for 11, I'm going to put that right here, 18.529. Okay, now remember, we're going to take, for this cell right here, we're going to go ahead and take that column's total times that row total, because, see, that's where they intersect in that cell, and then we divide by 272. Okay. So can you help me out with light and non-diabetic, this cell right here? So we've already got this one taken care of.
So I got 71.47.
Perfect. Daniela says 71.47. We'll go ahead and take it to 3 decimal places. Now, because we're looking for 79, okay, I'm going to go ahead and make sure to put that next to the correct value. See, I don't want to just put that in order. I want to put it next to its correct observed data. Okay, that's an easy mistake you could make. 71.471. Perfect. Okay, so we have those two down. Now I'm looking for 19, the medium and diabetic. Okay, so let me go ahead and set this up real fast. What do we got here? So what should I be getting for medium and diabetic?
I got 17.912.
Perfect. Now we're doing that for 19, so I'm going to put 17 point, what was it again, 912? Perfect.
Yes.
So that one's done. Is everybody okay with how we're doing this? Okay. Now the one thing about your IA, depending on the strategy that you choose in order to analyze your data, like if you choose chi-squared, if you choose correlation coefficient, you do want to go ahead and show your work. Now you can still do it on the calculator, maybe even have a little portion where you compare the two, the technology answer versus the hand answer, okay? But you do want to go ahead and show everything we have here. Okay, what about the 68, medium and non-diabetic?
69.08.
Okay, so let me catch up here real fast. I got 69.088, is that what you're saying, Bill? Okay. So 69.088, fantastic. Okay, now we're down to our last two. Is everybody okay with how we're doing this? Is everybody feeling a lot better about it? Okay. All right, so who's going to help me out? Who did I have for heavy and diabetic? That was Zuzu, and who was helping you? I think it was, Alwyn was on yours, right?
Mm-hmm.
Okay. So Michelle, I think you and Zuzu were working together? Okay. So let's see, for heavy and diabetic, let me go ahead and put this in real fast, and we'll confirm our answers. Control divide. Oops. Okay, Zuzu or Michelle, what are we getting for heavy and diabetic as an expected value? Perfect, 19.559. Again, I want to make sure to put that in the correct spot. Since we're looking at 26, I want to put it next to 26. 19.559. Okay. And then our last one here heavy and non-diabetic. So let's see here. Control divide. Okay. So what are we getting? Michelle, can you help me out with this one? What's the expected frequency value for a heavy individual who is non-diabetic? Okay, Michelle says 54.794. I got something a little different. Zuzu, what'd you get?
75.
I got 75.441 as well. Okay, 75.441. Okay. So Michelle, for that last one right there, the expected frequency value for heavy and non-diabetic, I would take the column total 95 times the row total 216 and then divide that by 272. Okay. All right. So now let's go ahead and see what the rest of this is. Now remember, the table we set up is a progression to go ahead and make things really easy on us. So I'm going to go ahead and take 11 minus 18.529. I'm getting negative 7.529. And now I'm going to go ahead and square that. So I'm getting 56.686, let's say. Okay. And you guys can confirm this in the calculator. Okay. So now I want to take this square difference and I want to divide by its respective value. So I'm going to divide by 18.529. So I'm getting 3.0593. So let's say 3.060. Again, we'll go ahead and round it to 3 decimal places. Is everybody okay? Did I make a mistake?
No.
Yes, sir. Oh, yeah, sure. Now, one thing I'm also hoping that you're going to see while working this problem is, you know, the benefit of knowing it by hand, but also how fast the calculator makes it. Okay, 12, today is the 7th. Timeout, 3:32, 22:04, west. Okay. Okay, does everybody agree with what I got here? Okay. Let's go ahead and run through the next one. So I've got 19 minus 17.912. So this gave me 1.088. I'm going to go ahead and square that. 1.184. Okay. And then I'm going to take that square difference, divide it by 17.912. So I'm getting 0.0661. So I'll say 0.066. Okay. And remember, I'm just doing this very quickly on the calculator. Please, confirm or let me know if I'm making a mistake on these. Okay, next up, 26 minus 19.559. I got 6.441. I'm going to go ahead and square that. 41.487. Then I'm going to divide that by, again, its expected value. So divide that by 19.559. So 2.121. Next up, 79 minus 71.471. I got 7.529. Let's go ahead and square that. 56.686. Now I want to take that 56.686 divided by 71.471. 71.471. And I'm getting 0.793. Okay, we're almost there. Almost done. Is everybody okay with what I'm doing? Anybody lost? Okay. Running through mine as well. So 68 is next up. 68 minus 69.088. I'm getting negative 1.088. We're going to go ahead and square that. 1.184. And then we're going to divide that by 69.088. So I'm getting 0.017 for this one. And we're so close, we're almost to the end here. One to go. And I really hope I haven't made a mistake here. Let's see, 69 minus 75.441. So I'm getting negative 6.441. Now I want to go ahead and square that. 41 point, let's say 487. Now I want to take 41.487, divide by its expected value. So divide it by 75.441. I'm getting 0.5499, so I'm going to say 0.550. Okay. Now I'm going to take a grand total here. So let's see, 3.060 plus 0.066 plus 2.121 plus 0.793 plus 0.017 plus 0.550. I'm getting a grand total of 6.607. That should be my chi-squared calculated value. Okay. 6.607. Okay, remember we were already told that our critical value was 5.99. So how do they compare? Our value is what? Greater than. So remember, what do we do in the instance that our calculated is greater than the critical? This is what we have right here. So they are not independent. We're going to reject the null hypothesis. Now remember, we don't say we accept the null hypothesis because you could get a different outcome with a different level, maybe 1 or 10%. So we're going to go ahead and say we fail to reject the null hypothesis. So is there a relationship between weight and being diabetic or not? I mean, just when you really think about it, what would you say to that? Yes or no? Yeah, there's a definite relationship between the two, and this test kind of helped us see that. Now, again, what's the relationship? Well, that's something that we would have to think about. Okay. How are we doing? That's a lot of numbers. We went through a lot right there. Now, let's go ahead and take the same thing. Let's plug it in the calculator. Let's see how close we got to our actual value. Hopefully, it's going to be pretty close. The only thing you're not going to be finding by hand is the p-value. So we still want to go ahead and take a look at that as well. Okay? So we did this yesterday. You guys help me out. I'm going to go ahead and take our values here, our observed data. I'm going to recreate this contingency table in my calculator. Okay, so I'm going to come on over here. Let me document B out of here. Now, in order to put a matrix into the calculator, we went to this button yesterday, right here between 9 and the open book, right below delete. Now, because it's a 2 by 3, I'm going right here to the 3 by 3. This is the only one where it allows me to go ahead and change the number of rows and columns. So I'm going to go ahead and put in 2 by 3. And now I want to put in the data. Okay, so that would be 11, 19, 26. Okay. And then I also want to go ahead and put in 79, 68, 69. 79, 68, 69. Did I get those numbers correct? 79, 68, 69. Yes, okay. So now, what did we do yesterday? There's something we got to do with this matrix. We have to name it, okay? So we're going to go to Control, Variable, because you see the Control button is going to give you this store option. It's going to give you this arrow. You can name this whatever you want. Typically, I just go ahead and name it a letter, like say X. So now the calculator knows X to be this 2 by 3 matrix, okay? So let's actually perform the test. Let's go to Menu. Where do I go from here? Statistics. We want stat tests. Very good.
And that's right.
The two-way test, because remember those contingency tables, we also call them two-way tests. Okay. Now GOF, that's goodness of fit. We're going to be looking at that at the end of next week. So two-way test. What matrix do you want to look at? Well, I named it matrix X. Okay. So let's take a look right here. What's my calculated value? 6.607. What did we come up with? Boom! Look at that.
Baby.
That's what I'm talking about. Let's go. Okay. 6.607. But see, look how long did it take us with the keystrokes versus finding all of those numbers? There's a huge difference, right? It really is. Is anybody confused by anything we did? Okay. Now remember, let me go ahead and show you a couple things. You remember we found the expected frequency values? Okay. We found each of these individually right here. Remember, you can do this in seconds on the calculator. Okay, on the calculator screen, I'm going to go ahead and push variable. Let me go ahead and use my mouse because I'm recording. So you don't have to hit control this time. If you want to see the expected frequency values, go ahead and click the variable button right below, or excuse me, above 9. It's going to give you a whole list. We want EXP matrix, expected matrix, the expected frequency values. Now I'm going to go ahead and click enter, and there we go. So take a look. It actually puts them in the correct cell as compared to the observed. So in the top left, we should have gotten 18.529. Let's compare that over here to 11 in the top left. See, we absolutely did get 18.529. It will go ahead and give you those correct values. And if you go back and look, they're all correct. Okay. But now let's go ahead and take a look at the p-value. All right. Now, the p-value here, it says it's 0.0367. So let's say 0.0368. Okay. Let's say 3 sig figs here. So 0.0368. This is my p-value. We're going to go ahead and compare it to my significance level. What are we testing this at? We're testing this at 5%. Okay, so I'm going to say 0.05. Remember, you always want to compare it to the decimal version of that percentage. So which is bigger, 0.03 or 0.05? So our p-value is less than 0.05, right? Now remember what we said on our original conclusion was that because our calculated was bigger than our critical, we're failing to reject that null hypothesis, okay? So that means what? Okay. They're not independent. Oh, did I say fail to reject? Oh, that is my fault. I'm sorry, we should have rejected that. We came to the right conclusion, but yeah, I'm sorry, there is a relationship between the two. I was just saying if you're paying attention. There you go. Now let's go ahead and try the p-value. Take a look at this right here. So our p-value is less than our significance level. So again, it does say what? Reject the null hypothesis. So weight and being diabetic or not, there is a relationship between them. Okay. Sorry, I only made one mistake. Dadgummit. I was so close. But there you go. That's chi-squared. Is anybody having a hard time? Is anybody confused? Let me ask you a question. Did anybody notice that I accidentally put the wrong conclusion? You did notice, Bill? Oh, he wasn't in here. Anybody notice? Ryan, did you notice? Ryan shaking his head no. Okay, Dylan, Ryan, Dylan saying that you noticed and he told you, or you told him. There you go. Okay, but is this making sense? Okay. All right, good. So you have some more problems to go ahead and do. Again, I mean, if I were to go ahead and have you work on one more than the other, I would definitely say make sure you feel more comfortable with technology, because that's how you're going to be working these problems on the paper exam. If you do end up using this on your IA, you are going to want to show it, full out. Okay, but definitely what's the more important of the two? I would have to lean towards technology. So on number 2, if you decide, you know what, I think I'm understanding it, I'm just going to go with the keystrokes, I'm not going to hold you to that unless you just really want to. Okay. All right. So you have, how many questions are on this sheet here? 4? Just 4? Yeah. So only 3 more to go. I'm going to go ahead and turn you guys loose unless you have any questions. And I'm going to go ahead and let you work on your paper. If you have any questions, please don't hesitate. Let me know.